So hello guys, in today's video we'll be solving the question leetcode-114, which is flattening the binary tree to linked list. Now this question can be a tricky, and I would say this is more of a, if you take this test case like the given tree which is given, it can be a little bit confusing. So try to I'll try to make the video as simple as possible so that you can understand it clearly. Now, yeah. So basically, give me a second, guys. Yeah. So basically, the question is asking us that from the binary tree, from the given binary tree, we have to construct a linked list. Okay, we have to flatten the binary tree, and we have to flatten towards the right. This is one kind of a pattern, you can say. We have to flatten to the right. And how is the tree flattened, that is also a matter of fact. For example, like here, see, can you see this 5 and 6? The 5 and 6 are coming at the last, at the very last. So we can say one thing, that the right part, the right subtree, is coming out to be the tail of the linked list, and the left part, and the left part and the left part is coming before the right part and after the node. So the left part is in between. Okay, see guys, the left part, this tree, how do I this tree is coming out to be here, and these guys, this right subtree, are coming out at the tail. So we can say one thing, that the right subtree is coming out at the tail of the linked list, and the left part we have to rearrange into this part. Okay, now I'll just take this example to show it more clearly. Basically, what we have to do is, we have to we want this, then we want this, uh, then we want this. Basically, now we have to connect this thing with this thing. Okay, now this is 1, this is 2, and this is 3. So what is happening here? How will we do? First, first of all, the base condition, first of all, if we don't have any node, then just return none. But what if we only have node, we don't have, neither we have left part, nor we have the right part? So what we'll do, we will return the node itself. now 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 what we are going to do is, first we'll connect the left part, the left tree, to the right part, and then we'll dislocate this thing. We'll just remove this thing, and 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 what we'll do is, we'll connect this thing here to this part, and we'll remove this part too. I know this is kind of confusing, like how are, like, you just broke the pointer and you just connected it, but how will we do? I'll show them in the code as well, and in the code I think it will be very much clear to you. But this is actually the idea of this question, how we have to proceed. We have to just remove this part, we have to remove this pointer. We have to connect the left pointer, the left tail, the tail of the left, to the right part, and then the root part, which is the node, we have to connect this part to the left subtree. Okay, now I'll just take out, we'll just code, and I'll just, while I'm coding, I'll tell you what is happening and how will we proceed. Okay, first of all, we'll define DFS. Of course, guys, we'll use DFS. I mean, that is very much obvious for this question. Uh, if not node, then return none, and if not node dot left. And basically, in this thing, what we are doing is, return node. If we don't have left and the right child, then just return node. Okay, now we want left tail and right tail, so we'll make a variable. Basically we'll call the left tail, which is node.left, because first we'll go to the left part, that's why we are traversing. I call node.left, and then the right tail. And guys, can you see one thing? I just wanted to tell you one more thing. Can you see the order? Like, what are we doing here? Basically, this is a problem like a pre-order. First we have root, okay. Then we have the left part, and then we have the right part. First we got the root, then we got the left guys, then we got the right guys. So now what we are gonna do is we are gonna implement it in such a way that the uh, will reverse the pre-order part. Don't just get confused. I just want to give you the idea. You just see the code, and I hope it will be more clear to you. I think till now I'm clear. Now what will we do is, if we have the tail, now we are at the very much crucial part, this thing. Okay, basically wait. Now what we are gonna do is, the left tail will connect it to the right, because we want this to be in between. So what we'll do is, if left tail, then left underscore tail, the right part will connect it to the node dot right. We have connected this to the right part. Now what about the node itself? What about the node? The left part is obviously, now it will be none, as we don't want anything here. Okay, like this, it's none, so we'll return none. But what about this guy? What we did here is, we connected the left part, the node of left to this guy, right? So node of left is connected to can I say the right part? As we can see, the node of left, one second guys, so sorry, here we won't connect, the left part is going to be null, we want the right part. Basically the right part, we are connecting the right part to this node. Okay, so what we'll do is, node's right part will be connected to now node's left part. Basically this pointer is going to be connected to this pointer. So what will we get then? We'll get this. We are connecting the right part to the left of the node. Okay, now we'll return right underscore tail or left underscore tail. Okay, and we'll call this guy. I hope this works. Okay, so we got a wrong answer. Why did we got a wrong answer here? One, two, five. This right part. We're not getting the null part. Yeah. So guys, why we are getting the wrong answer? Basically, I did a typo here. I missed this not, and now will be accepted. And one more thing, I want to tell you one more important thing in this is basically let it just get accepted. Yeah. Now the important part which I have to tell is we can't reverse this order. For example, for example, if I return the left part first, okay. Now and then I return the right part. Now it will give us a wrong answer. But why? Because when we are returning the left tail, okay, then it goes to the left. It goes to the left. It goes to the left part here. It goes here, and then if this is none, okay, if it goes to the left part, and if this is none, then it does not check the right part because it thinks here it is the end here. It is the end here. Okay, it basically thinks there is no more afterward, and this is the end here. So first, we'll return the right part, and then we'll return the left part. Why? Because the right, I already told you in pre-order. In pre-order, it is basically reverse pre-order. So pre-order is basically left root, then left, then right. Okay. Now what we are the idea of this question is basically we are reversing the pre-order. We are reversing the pre-order. So right should come first. Okay. Then left, then root. According to this idea, first we'll return the right part and then the left part. Because if we return the left part first, then basically we don't know the end. We think the end is at the left part. Okay. So I think I'm very much clear right now. Okay. If you still have any doubt, then ask me in the comments. I'll try to answer it. Thank you so much, guys.